Hello everyone, today we will be going over the system design course today, and today we're focusing on the concept of query languages. Now, in the realm of data management and retrieval, query languages play a crucial role. They are mediums through which users communicate with databases to fetch, insert, update, or delete data. So, query languages. They're designed to fetch, insert, update, or retrieve data, and also delete. So query languages are designed to fetch, insert, update, retrieve, or delete data. And among the various types of query languages, SQL, which stands for Structured Query Language. Let's do a different color over here. Structured Query Language. And as we know, SQL is also used widely for relational databases. And for every data system, we always need a database, cache, and queue. So, SQL stands out as a declarative language, contrasting sharply with imperative approaches seen in older systems, such as what we have talked about with the codicil system. So, for example, so we have already stated that SQL has already been proven to be superior compared to older systems, such as codicil beforehand. Let's move this over here. Give me a second. And I'll just minimize this. Mostly because of the ability to be able to search and modify data is a big reason why. And in previous lectures, we have already mentioned about the history between the establishment of relational and document databases and how relational databases emerge superior compared to the traditional setup of codicil. And the distinction is fundamentally alters how queries are constructed and how databases interpret and execute these queries. So in general, in order to actually execute these query languages, imperative programming in languages such as Java, Python, or C require programmers to explicitly outline the steps needed to achieve a desired outcome whenever we are communicating with a particular database. It's much like in the case of providing instructions over saying, I want this piece of information from where I'm standing, and this is what I want it to do. And it could be of a variety of different functions. For instance, if you are a marine biologist looking to filter out sharks from a list of animals, one would typically iterate over a list and check each item's family's attribute and collect the matches. So just to give an example, 1 second. So we would iterate through a list, to get data. For example, I'll just use a different color for this. EX marine biologist searching for a list of sharks. There we go. And conversely, declarative query languages like SQL and combined with theoretical algebra, they base the operation on multiple principles and instructing specifically of detailing how the process is done over how would the language in of itself extract the data, and then focusing on what the desired end goal is. So with SQL, is made to retrieve a set amount of data from a database and to instruct the database on how to search. It's mostly just whenever we're talking about queries in general, we are trying to focus more on actually retrieving the data and communicating directly with the database. So overall, we are focusing on communicating with the database. The database. And also, languages such as SQL naturally are pretty handy when it comes to parallel execution, such as whenever one needs to either make multiple queries or also focus on actually achieving, for instance, a desired task that requires multiple computations, such as leveraging multiple CPU cores, or utilizing distributed systems whenever one needs to, for instance, create a certain application or create a model, depending on exactly what one wants to build. And while such code might be used to be able to alter different queries and also execute parallel distributions, there might be significant restructuring declarative queries that are initially having a first-hand assumption, but there needs to be further depth to be able to see exactly what explicitly is going to be retrieved within the database and what series of tasks need to be executed. For the rest of the lecture series, we're also going to go over further concept examples that will actually demonstrate some SQL code, which are actually, aside from the syntax, are pretty intuitive, but really we're just trying to search directly within the database to achieve and retrieve what we are trying to obtain. So let me just zoom out of here. Apologies on that. Oop. Those are for later. And here we go. Here's the first part. There we go. Now to go over a concept example, let's imagine a library database containing millions of records, each representing a book, author, genre, publication year, and availability status. A librarian wants to find all available science fiction books published after 2000 for a themed display. We use an imperative approach. The librarian would need to script a detailed procedure. One, they need to loop through every record. So, one, loop through every record. Check the genre. And publication year. Then check if the book is available. And if it's available, we collect it. And so we have a following example up here for the SQL script. By all means, feel free to take a screenshot and be able to put it in your own notes as well, where we are selecting from the whole library of books, and we're looking specifically in genre. And mind you, we are focusing on a relational database as well. So So we have a relational database query. And with the relational database query, we already have a whole library of books that we're going through. And another component of the relational database is going to be a genre. And we're looking specifically for science fiction as a genre because we have already documented that inside of our database. And also, we have a publication year as well to be able to specify when it was already published. And we're checking to see if it is available. If it's available, it's true, and we collect it, and we have these conditions that are already set up in place. So typically in JavaScript or Java, for instance, you would typically have a for statement to be able to loop through a given list, but SQL makes it very intuitive to be able to write out specifically if we want to select a specific book with a specific genre and publication year, and we're checking to see if it's available. If it's available, we collect it, which is the true statement, the end goal that we have. So we already have a genre, that's one condition, a publication year, and we're checking to see if it's available. So we have 3 different components that we're seeing to check if it is ultimately available. So let me just erase this to be able to showcase what we have: science fiction, publication year, and is available for true. And if it's true, we collect it. So to be able to submit our concept, let's go over a practice problem. And this time what we are doing is that we are creating a university database storing information for students. So just be able to go over. We are storing student information for students in a university. And while we are doing that, we are focusing on the information of students, courses, and enrollments. The database needs to generate a report of all the students who have enrolled in a specific course, such as introduction to databases for the upcoming semester, and this report should include the student's ID, name, and the course details. So actually, to be able to help highlight this, I'm going to move this ID all the way to enrollments. One second. There we go. All right, and so what we have the following SQL query over here that's really just focusing on the students or what we are facing. So we already know that we are selecting students based on the ID name right over here, the course name, and we also have a course semester at the same time since we are just using that for small detail as well. And so what we are doing is that we are focusing on key components within our relational database, such as the students, enrollment, and courses, because these are fields that are already created within our relational database. And so what we're doing is that we're using the from command in order to actually be able to call upon a relational database, the students, and we have to combine the enrollments and the courses as well based on the student's ID that we already have. And this .id is really pertaining to the field of students that we have based on ID, name, and then also the courses based on course name and course semester. So this ID technically is also in the name. There you go. Now it looks like the course ID is already, based on enrollments right over here. So what we are doing is that we're selecting within our relational database to be able to, one, understand the join operation in SQL, which is essential for combining rows from two or more tables on a related column. So to be able to give a breakdown, join represents combining two or more rows from a table and in our example we need to join three tables: students, enrollments, and courses. So these are three tables altogether in our database. And the enrollments table acts as a bridge between students and courses. Equals a bridge between students and courses. And it's mostly just based on the records of the student's ID and the course ID. So let me see if we can move over a little bit more. All right, based on the student and course ID. There we go. So technically the SQL join clause is used to combine the rows of two or more tables in conclusion. And it's just based on joining the operations to connect the students table and enrollments table based on student ID column. So it allows us to associate each student with the respective enrollments, and we join enrollments with the courses also based on the course ID. And to be able to break down further on this, we also have the, let me see if I could just move over a little bit more. We have the where clause finally. And where represents the filtration of the data see if I can just move this over a little bit more. There we go, a little bit more. Okay. Oop. The where clause in SQL is used to filter the records to fulfill a specific condition. Here it serves two purposes. So I'll just put it right here. Two purposes. One, it only specifies what we're interested in the course name. Specifies what we are interested in. Course name wise. And then the second part pertaining a double filtration for the semester. Hence we already have the name and the course semester as well to get what we need for where. And overall, the double filtration ensures that the report generated will exclusively contain records pertinent to the specific course and semester of interest, therefore allowing us to be able to get a targeted query to be able to get specifics on what we are searching for. So let me just zoom out. There we go. And let me erase this. And so now let's look at our second practice problem. Now let's consider a different situation where the university wants to identify students who have not enrolled in any courses for the upcoming semester. This is to reach out to them with information on course registration deadlines and academic advising resources. So we are focusing on students not enrolled. And so based on our query that we already have, we already select within our students databases, and we're using the from students in this table, and then we have left and join, which is what we will be focusing on. So with the concept of left and join, in this scenario, the concept of left join is becoming pivotal. Unlike inner join, where we just have regular join and what we already explained in the first problem, a left join ensures that all records from the left table, so it focuses on the left table, are included in the results set, even if there is no matching record on the right table for students enrollment in fall 2024. The left join clause in SQL is designated to return all records from the left table, so as specified before, and the match records from the right table are enrollments. The results become null. Sorry. From the right side if there is no match. And then, as well, going through our query, by specifying the semester in the on clause of the left join, we filter the enrollments at the joining stage itself, focusing on fall 2024. The condition where enrollment course ID is null ensures that we only select those students who have not enrolled in the matching courses. So focusing on students not enrolled, and we use null for that. And then the second part that we also need to consider as well is the where clause that we have. So the use of where enrollment's course ID is null is focusing on students that are just overall not enrolled. And this is just our basic practice problem that we have, just with different SQL queries. And SQL is pretty intuitive by nature whenever we are manipulating data and or trying to extract data. We're just giving databases instructions on what we are looking for specifically to be able to search throughout the rest of our database that we need. For every data system needs a database, cache, and queue. And so, yes, this was just a concept of query languages. Thank you again for taking time to watch this. If you found this video helpful, be sure to like and subscribe, and feel free to. And if you have any questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.